So today we're going to be looking at the guide for the next Chapter 8 quiz. This is on equations and inequalities. We're just going to take a look at how these problems are meant to be approached and solved. So the first set we have here are just pretty basic solve the equations, showing your work, of course, so that we know what we're doing. And again, the goal when solving equations is to get the variable by itself. That's the entire point of solving an equation, is to get whether the x or y or a or b or whatever the variable is called. We want to get that by itself on its own side of the equal sign. We don't want any other number with the variable. So in the end, our answer should look something like variable equals a number. And that's what we're trying to solve for, is what does that variable equal? What's that variable worth in the equation? So for the first one, we have x minus 6 equals 9. And the most basic way of solving an equation is to simply do opposite operations to undo what's happening to the variable and then isolate it. So for example, if I see x minus 6 and I just want to get x by itself, well, how do I get rid of this minus 6? Well, I'm going to add 6, because adding 6 to a minus 6 cancels it out, and I'm just left with x. Now, the golden rule for equations is whatever you do to one side, you have to do to the other in order to keep it balanced. So if I added 6 to the left, that means I have to add 6 to the right. And 9 plus 6 ends up being 15, which ends up being my answer. So you look at what's happening to the variable, what's the operation, do the opposite, and apply it to both sides, and then that's it. Usually these all can be done in one step. To make sure you keep your sides straight and balanced so that you don't kind of mix sides together, what I tell people to do is draw a line straight down the equal sign. That helps give you two distinct sides. That way when we refer to doing something on this side or doing something on that side, you know what we're talking about. So in this case, it's 3 times x equals 18. Remember, if the variable is right next to the number, it implies multiplication. So this is 3 times x. So to get rid of 3 times x, I'm going to divide by 3. I'm going to divide by 3. This is going to go away. I'm going to be left with x. And then 18 divided by 3 is going to give me 6. And that'll be my answer for that one. Other ones go pretty similarly. I'll draw my line down here. X plus 7 is 23. So to get rid of plus 7, I'm going to subtract 7 on both sides. And again, subtracting 7 and adding 7, those cancel out, because if I add 7 to something and then take 7 away, it's like it never happened. And then on this side, I get 16. Again, look at what's happening to the variable, do the opposite, and you're done. When you have a fraction being multiplied to a variable, though, there's two ways you can go about it. The first way is just to kind of keep the straightforward approach, is just doing the opposite. So for example, this is 2/5 times x. Well, to get rid of 2/5 times x, I'm going to divide by 2/5, which would cancel them out, and be left with x. And over here, I divide by 2/5. The only thing you have to make sure you remember is that when you divide by a fraction, it flips and make that 5 a little bit better so we don't think it's a 6. So when you divide by a 2/5, that fraction should flip, and then the division flips to multiplication as well. So it look like this: 7/10 times 5/2. So remember, when you divide by a fraction, the second fraction flips, and you change to multiplication. If you do some quick canceling here, 5 and 10 can both be divided by 5. And then that's about as much canceling as I can do. So 7 times 1 is 7. 2 times 2 is 4. There's your answer of 7/4. Now, fractions have another way of being solved if they're being multiplied to the variable. I'll do a quick example of that one over here. So if, let's say I have the same problem, 7/10. If I want to solve it, one way I could do is take the fraction apart piece by piece. So for example, this 5 is dividing the x. It looks like it's multiplying, but when the 5 is on the bottom of a fraction, it actually implies division, not multiplication. Because what that fraction really is saying is 2 times x and then divide by 5. It's just not shown as clearly as it might usually be. So if I want to get rid of the denominator 5, what I'm going to do is I'm going to multiply by 5. If I times by 5, that goes away, and I'm left with 2x. Once again, the golden rule, times by 5 over here If you want to make this a little bit easier to see, you can say it's 5 over 1, because remember, any 5 can be changed to 5 over 1 if you want. Do some fraction canceling, divide by 5, divide by 5, times it out, and you get 7 halves. Or if you want to put it more appropriately, actually, we'll just leave it as a fraction for now. We won't bother with the decimal form. So the next part's going to be easier to see with the fraction anyway. So the next part of this is to then divide by 2, because now we have 2 times x, so we're going to divide by 2. And then we're going to divide by 2. I'm going to write like this for over here. And I get x is equal to 7 halves divided by 2. Again, you can think of the 2 as a 2 over 1. So once again, you flip the second fraction and change it to multiplication. And so you get 7/4 there. Remember, any whole number over 1, you can write any whole number as itself over 1 if you want to make it to a fraction to do some work with it. So both methods of this solving for fractions work. As long as you pick one and you can do it, you should be fine. Number 5 is a division equation. We have x divided by 4, so it looks like a fraction, x over 4, but as I said last time, fractions are essentially division as well. So when you see x divided by 4, or when you see x over 4, think x divided by 4. So I'm going to times by 4 to get rid of that. Times by 4, I get x equals 64. So the first part of this quiz here is just making sure we understand how the equations work, how they're balanced, and how to solve them. Okay? Again, they start out balanced. You remove stuff from each side by doing opposite operations. And as long as you're doing it to each side, you keep it balanced, and therefore your answer becomes apparent once you get rid of all the numbers that you need to get rid of from the variable. Word problem-wise, there's no real difference. You just have to make sure you set it up correctly. So remember the keywords: sum is addition, difference is subtraction, product is multiplication, and quotient is division, along with a few other words here and there that mean them as well. So this one says the difference of a number and 10 is 48. What is the number? Well, let's first write down the equation. The difference means we're going to subtract a number, so we'll call that n, and 10 is means equals, and then of course 48 is 48. So subtract a number and 10 to equal 48. Okay, let's do that. Subtract a number and 10 to equal 48. Just kind of write it as you read it in this case. Almost forgot the top 8 there. So now that we have the equation that's just like the top pieces, we figure out what are we going to do to solve this. Well, right now it's n minus 10. I don't want the variable to be done with any other number there, so I'm going to add 10 to both sides. And that'll give me n is equal to 58. So remember, difference meaning subtraction, so it's just first thing minus second thing, and then is being equals, and then of course the number just being itself. The key word there being is. You have to remember that is means equals, because that's going to help you set up your equations right. Just like the next one here. So 32 less than a number is 120. So we have is 120. So we know that side's going to be set. 32 less than a number. Less than is kind of a tricky word. It means subtraction, but kind of in reverse. So instead of writing the first thing first, you're going to write the second thing first. What I mean by that is it says 32 less than a number. So what we write down is a number minus 32. It's not like the first one, we can just write it as we read it. This way, we have to pause and think, okay, 32 less than a number means I had the thing first, I had the number first, and then I take 32 from it. So you cannot have less than the number if you don't first have the number, which is why the variable is going to come first in this case. And then to get rid of subtraction, just like we did above, addition, and we get the number is equal to 152. So once you have your equation down, it's just a matter of find the operation, do the opposite, and then you're golden. One more of these word problem ones here. 1/4 the cost of a sweater is 40. What is the cost of the sweater? Again, is 40, so equals 40. Making sure we get that equal sign in there. 1/4 of the cost of the sweater. So the word of, especially when we use the fractions, the word of means multiply. So 1/4 of the cost means we're going to have 1/4 of, and now the cost we don't know. Since we don't know the cost, we use a variable. We'll use C for cost. So 1/4 of the cost of the sweater is 40. So that's how we have it here. 1/4 times the cost is 40. If we want to solve this equation, again, it's a fraction. So what we're going to do is we're going to divide by 1/4. Divide by 1/4. And we get C equals, again, these cancel out. 40 divided by a fourth. Remember, you flip the second fraction, so it's actually like timesing by 4 over 1, which is just 160. It's basically timesing by 4. So the cost of the sweater is $160 because 1/4 of that would be 40. So again, read the equation, or read the sentence rather, figure out what the operation is, then write your equation. The next ones deal with inequalities. Inequalities are very similar, except that inequalities use one of the 4 symbols here. Greater than, less than, greater than or equal to, less than or equal to. It has to have one of those 4 symbols in order to be an inequality. So all of these word problems here are going to result in one of those 4 symbols in their writing. So the student must earn at least 94% to earn an A, and then they give us the variable here, G, to stand for the student's grade. So we want to model this statement as an inequality, okay? Well, we're going to have the variable G, so their grade is going to be compared to 94. So how does their grade compare to 94? It says you have to have at least a 94 to earn an A. So I can have more than a 94, that's okay. So my grade can be more than 94. My grade can also be equal to 94 because it says at least. So that means 94 is at least 94. It just can't be less than 94. So that's the symbol we're going to use there, is the greater than or equal to symbol. Because we can be greater than the 94 and we can be equal to the 94. So since we can be both, we use the greater than or equal to symbol rather than just the greater than sign. So we're going to make our inequality here. I use the 3-point method, which means you just draw a 94 in the middle. One number bigger, we'll say 95. One number less, we'll say 93. And then you're going to graph your graph off of this number line. So remember, these 2 symbols both used a closed dot when you graph them. These 2 symbols use an open dot when you graph them. The reason is because the or equal to symbols means you can actually be that number. So if x is bigger than or equal to 5, that means 5 can still be the solution. So I have to make sure I include that with a closed dot. Whereas if I said x is just bigger than 5 rather than bigger than or equal to, then I have to put an open circle on 5 because I can't actually include 5 in that case. In this case, I can actually include 94 in my answer because it's bigger than or equal to. So I'm going to put a closed dot right above 94. And the grade is bigger than or equal to 94, so I'm going to point to all the numbers that are bigger than 94, which is down this way. So 95, 96, 97, so on. And that'd be how my graph looks. So your graph, remember, comes in 2 pieces. It comes in the dot and arrow, and it comes in making sure the numbers are arranged correctly. So put the dot over the number you start with, draw the arrow to the numbers that are in the same direction that you want to go. The next one here, very similar problem, just a bit different numbers. A person decides to spend no more than $1,600 on a vacation, and then M is the money they actually decide to spend on the vacation. So we have the variable M being compared to 1,600. And we want to know what symbol is going to go in between this pair. Well, it says the money can be no more than 1,600. So that means the money can be less than 1,600. That's okay. Our money can be less than 1,600, 1,500, 1,000, 900. Those are all okay numbers. And since it says no more than, that means our money can be equal to that as well, right? Because 1,600 is no more than 1,600. So it can be okay being equal to 1,600 as well. So that's the symbol we're going to go with there, is M is less than or equal to 1,600, because both 1,600 works and anything less than 1,600 would also work for the budget that they're giving us here. If I go to the graph, once again, using the 3-point method here, we have 1,600 in the middle. We have one to the left, I'll put 1,700. One to the right, I'll put 1,500. Again, it doesn't have to be exactly 1 or 100 off. You can put any number you want that's bigger than 1,600, any number you want that's less than 1,600 as the left and right points. So because it's an equal to sign, I'm going to put a closed dot right above 1,600. Making sure I put a closed dot there because it's less than or equal to, so I can be 1,600. And because I want the numbers less than or equal to 1600, my arrow is going to go this way, pointing towards the 1500, because that's what the numbers that are less than 1600 are. So to summarize this last little bit here, again, you're going to want to read the equation, or sorry, read the sentence, and then decide which inequality you're going to use in your modeling. Greater than, less than, greater than or equal to, or less than or equal to. And remember, the greater than or equal to and less than or equal to, those are both closed dots. The greater than and less than, those are both open dots when you go to graph them. And just make sure your arrow points in the right direction. So when you're taking these inequality problems, read them carefully, piece them apart bit by bit, so you don't mistakenly use the wrong symbol, because it's a very easy thing to do. That's it for this one. Hope you enjoyed the video. Have a good day.